Welcome everyone to this Kubernetes clinic featuring Datadog today. We're going to start with a quick poll and just go ahead and dive in and ask where folks are on their Kubernetes journey. So Dave, if you want to pull that up and we'll get the poll started. So there's a couple different options here. I'm learning about containers in Kubernetes. I've spun up a test cluster. I've started using it in pre-production. I'm using it in production. If you want to go ahead and spend a second filling that out, it gives us a little bit of an idea of where you are in your journey so we know how to talk to the audience that's here. And 10 more seconds. Okay, you can wrap that up, Dave. Okay, and we'll just dive in, tell you a little bit about Fairwinds first, and then we'll get over to Ara and Datadog. So Fairwinds is a Kubernetes enablement company. We offer what we call an enablement platform. So that's a combination of services, open source, and software to build and maintain infrastructure around Kubernetes. So it's my belief that everybody would be switching to Kubernetes if they thought they could do it securely, reliably, and efficiently. Most people are afraid of that, so we have different offerings in this space. Our service is for folks who come and say, hey, make my problems go away. We can build and maintain Kubernetes infrastructure for you. We do that over the long term. We have a bunch of automation and software that gets us to production grade infrastructure very quickly on any of the 3 major clouds. For people who are already running some Kubernetes, we have a suite of open source tools. You can go pick those off individually. We also offer support behind some of those that are more mission critical, that addresses things such as role-based access control, management of where your container registry is in case one goes down, which is something that we see a lot in managing lots of production infrastructure. Gosh, we have open source tools around checking that what you're deploying into your cluster is healthy, et cetera. There's a whole bunch there. You can look up Fairwinds Elements if you're curious about that for a list of all the open source. And then finally, we do have a SaaS product called Fairwinds Insights that does go through and tell you if what you're running in Kubernetes is secure, reliable, and efficient. And that's got a dashboard for you to dig through everything and come up with what's wrong and know how to fix it, as well as sits in the CI pipeline, includes admission controller, also has support for OPA if that's something you're interested in. So check out these things. That's who Fairwinds is. But today we're here to talk less about us and more about folks who are doing things that are significant in the Kubernetes community. And so we have Ara with us today. And Ara, do you want to go ahead and introduce yourself?
Sure. So I'm a technical evangelist at Datadog. I live in Spain. I've been working on Kubernetes projects for the past 3.5 years. Previously on a different company, now Datadog. And yeah, I'm happy to share the session today.
All right, and my name's Kendall. I'm the president at Fairwinds, so I've been here since basically the beginning of the company. Had every role therein, so from sales to engineering leadership to operations, I've done everything at Fairwinds as the company has grown. So glad to have you all here. And oh, that's the final poll. We're going to save that for later. I'm going to go ahead and stop sharing and turn it over to you, Ara. You can share your screen and dive into the talk today. And we can see your screen now, but you're muted.
Cool. Okay, so on the talk today, we are going to be talking about auto-scaling workloads in Kubernetes, how you can do that in a practical way. First of all, what it is, of course, and how you can do it. So most of you will know what Kubernetes is, but just so for those who are new, it's a container orchestration platform. Basically allows you to run your containerized applications in production, and it comes with very nice features like auto-scaling, auto-healing, and many more. So super useful and very successful project. And although this talk is not about Datadog itself specifically, we are going to be using Datadog in some of the demos. So you know, Datadog is a monitoring and analytics platform that helps companies improve the observability of their infrastructure and applications, including, of course, Kubernetes, not only Kubernetes, the platform, so monitoring Kubernetes itself, but also the workloads that you're going to run on top of that platform. But the topic today is scaling. And when we talk about scaling in Kubernetes, we can be talking about two very different things. We can be talking about scaling the cluster itself. So scaling the cluster basically means if you have 5 nodes in your cluster, adding more nodes to allow for more workloads to be in, or increasing the capacity of those nodes. So increasing the memory, increasing the CPU of those particular nodes. Or we can be talking about scaling the workloads that you run on top of Kubernetes. On the, yes.
Can I just comment there, Ara? This is one of the promises of Kubernetes is scaling, and you really should be auto-scaling and like listen to the things that Ara says today. But we do occasionally talk to a client who has been using Kubernetes in production for a long time and does not scale anything. And like, really, this is one of the big promises. So do this. Anyways, keep going.
Yes, exactly. This is the flexibility of containers using also an orchestrator like Kubernetes is one of the things that you should aim for when you're moving. So again, we are going to be talking about workloads scaling. So we are not going to touch on cluster scaling, that's a different talk. And in order to follow along a little bit, I'm going to introduce a couple of concepts. If you're not new to Kubernetes, this would be trivial for you, but just in case everybody can follow along. The first one is a pod, and a pod in Kubernetes is the minimal deployable unit. So basically, you can see here the yellow box there would be the pod, and it's basically one or more containers here in the green boxes that share the same networking namespace. So you can, if you have a couple of containers of the same pod, they can talk to each other through localhost, for example. And for scaling, the pod is also very important because you cannot scale containers individually. You cannot say, okay, from this pod, give me more units of this particular container. You have to scale the pod as a whole, and therefore you have to design your pods in a way taking that into account. The second concept is a service in Kubernetes, a Kubernetes service. Service is an overloaded word. So in this case, we are talking about the object, the Kubernetes service. So basically what it means is that because you can have several units of that same pod, we call them replicas in Kubernetes, then you have to have a method to direct the traffic to one or the other. So for that, there is this concept in Kubernetes called a service, which is basically a load balancer for the different pods that are part of that same service. And the third concept before we start doing something more interesting is Kubernetes scheduling. So how those containers end up running in Kubernetes. So if you think about the boxes up there as the nodes in your cluster, and the color boxes are the pods that are already running on those nodes, the way you have a new one running, a new pod, is by talking to the API server. Everything in Kubernetes happens through the API, which is also very extensible. So again, very flexible to work with. The way is basically you create a definition of this new pod that you want to schedule, and a lot happens in between, but just very high level. There is a component in the control plane called the scheduler that is going to basically pick the best node for that particular definition. So depending on your definition, it's going to decide which is the best node to schedule your pod. Okay, enough for the intro. So I'm going to be showing some concepts and doing some demos in between. The demos are pre-recorded because especially with scaling events, you need some data to come in and it takes a while. So everything is pre-recorded, but everything was recorded on the same laptop that I'm running here. So it's a local cluster using Minikube running 1.11. Also, we are going to be using an e-commerce application. I'm going to show a little bit how that looks like, because we are talking about workloads scaling. We need some workloads to work with. And finally, we are going to be using Datadog to get data about those workloads and making scaling decisions based on those. So this is our e-commerce app. Just to give you an idea of how it looks like. So we have here the front end. It's not only a front end, it's like a big monolith application. So we have this big monolith application with most of the logic is happening here on the store front end. And then we have a couple of microservices, one that serves discounts and the other one serves ads. And we also have everything backed up by a Postgres database. So just to give you an idea of how it's going to look like. And as we said, we're going to be using Datadog for getting monitoring data. So the way you get monitoring data from your Kubernetes cluster using Datadog is by deploying what we call the Datadog node agent. So these boxes over here. And the Datadog node agent is what we call in Kubernetes a daemon set, which basically is a special type of deployment in Kubernetes that basically ensures that at least one replica is running on every single node of the cluster. So if you add a new node after the fact that you have deployed that, it's going to create a new instance there. So the node agent is going to be responsible of gathering monitoring information from your containers running on that particular node, the kubelet, so the component that actually runs those containers, and the system information. So obviously you want also to monitor the system data from that, so RAM, CPU, etc. And then we have a second deployment here called the cluster agent. And the cluster agent is just a normal deployment. It's not a daemon set. You can have one or more replicas depending on your use case. But basically, the cluster agent is focused on gathering data from the API server. So it's more, it's relying on the API server information for the node agents rather than having every single node agent gathering that info from the API server. It has some other nice features for scaling, and those are the ones that we are going to be seeing today. Okay, let's start with the first demo. Well, the first video, just to show you the environment. So we have here in the environment the e-commerce app running. So you can see the front end here is going to be one of the most important services that we are going to see today. We have the node agent as a daemon set. We only have one because we only have one node. And we also have the cluster agent running. In this case, we have one replica. We could have more if we wanted to. So that's up and running, and this is the application. It's just a normal demo app, that e-commerce app, but it's already instrumented for tracing. So we have all the data of all the requests that are coming in, the latency of those services. You can have basically, you can have a visual way as well to see your application, and you can dive into any trace and see what is happening between all those services. So for any request, what services are taken, what is the P99 latency for a particular service, or P95, number of requests per second, etc. So all that info is already there. And with that environment, we are going to do vertical scaling and horizontal scaling. So starting with vertical scaling. So in vertical scaling, it's a little bit different in Kubernetes from what we are used to when we talk vertical scaling for servers, for example. When we talk about vertical scaling for VMs or for bare metal servers, when we usually talk about is the amount of CPU and amount of memory. So basically increasing the cores of a VM, increasing the amount of memory. But it's in Kubernetes, obviously we are talking about pods and containers, so it's slightly different. So what we talk about when we talk about vertical scaling, we are referring to the amount of CPU and memory that we are requesting for a single pod or a single container inside the pod, to be more precise. So when you're defining a pod and you're defining the containers inside that pod, there is a section called resources, and you can request some CPU and some memory for that particular container. So just so you know, we are usually use these units when we do that. Millicore for CPU, which 1,000 millicore is equivalent to a virtual core. And memory, we use MI or megabytes, which you can consider it roughly equivalent to a megabyte, although it's not exactly the same. So we have this definition, and what does it mean? So once we do that, we set up our resources request for a particular container, what it's going to mean in practice. So basically what it creates is a control with the scheduler. The scheduler was this component that we talk about in the control plane that decided which was the best node for a particular pod definition. So let's imagine that we have a node with a 1 gigabyte and 1 virtual core, and we want to schedule a pod with a container that is requesting 500 millicore and 500 megabytes. So at that point, the scheduler is going to say, perfect, I have the perfect node for this. I'm going to put it here, and the kubelet is going to start running those containers. Perfect. And now the scheduler is going to say, okay, I only have 500 millicore and 500 megabytes left on this one. And now I want to schedule a second one, which is requesting 600 millicore. At that point, the scheduler is going to say that there is no enough resources in our cluster for this particular pod, and it's going to mark the pod as pending. So if you've worked with Kubernetes before, probably you've seen some of your pods go pending at some point. There are many reasons why a pod can be in a pending state, but one of the reasons is that there is not enough resources. And usually what you do is that you're going to describe a pod that is pending to know the cost of what that pod is pending. So we have this contract with the scheduler. So what happens if we get it wrong, if we get those numbers wrong? So it can happen two different things. So let's imagine that we request too much, like we have no idea how much we need. So we say, okay, 500 millicore, 500 megabytes, I'm going to be safe. But then our pod is only using 70 millicore and 50 megabytes. What is going to happen is that you're going to underutilize your cloud resources because basically the scheduler is going to save all that space for you that you're not using. And obviously that translates into a bigger cloud bill at the end of the month. But what happens if we do the opposite of say, I'm going to request 500 millicore and 500 megabytes, but actually my pod uses more. So what happens here is that your pod is going to run, nothing, if it has a space, it's going to run, but the scheduler sometimes reshuffle pods around. So when it needs a space, it's going to decide to move some pods around or even moving some pods that were running back to pending. There is an algorithm for the scheduler to decide which ones, but one of the reasons why it would select your pod is if it's using more than it requested in the beginning. So if it needs a space, your pod may reschedule. And if it gets very frequent, it can be very annoying. And this is sometimes when people are migrating to Kubernetes for the first time, sometimes it causes some tension between the ops team and the devs because developers don't want their pod to be rescheduled all the time. They're used to something more stable like VM. So they say, okay, I'm going to request a lot and my pod is going to be more stable that way. And then you have your operations team that obviously is responsible to keep the resources well utilized and your bill, cloud bill low. So it's going to ask those developers to rethink those numbers. So how do I solve that question, especially at the beginning when I'm migrating my workloads and I have no idea how much should I request? So there is a component in Kubernetes called the vertical pod autoscaler that tries to solve that question. So basically it's going to give you recommendations for those numbers based on actual data. So the pod is going to be running for a while, and after a while it's going to say, okay, for this particular pod, you requested 500 millicore, 500 millibytes, but actually you should be fine with 200 millicore and 15 millibytes. There is 3 ways in which the vertical pod scaler can work. The first one, and the one that I would recommend everyone, especially if you're new to the VPA, to start using, is recommendation mode, because it's basically almost for free. It's going to use a component to gather information about CPU memory usage from your pods, and it's going to give you a recommendation for that particular pod. The second one is on rescheduling. On rescheduling is less radical than fully automated, but still it's going to start making changes to your pod. So on rescheduling means that the VPA is not going to force rescheduling your pod. So it's not going to kick it out because the numbers don't match. But if your pod gets rescheduled for whatever other reason, like your pod crashes, or the scheduler decided to reschedule your pod for other reasons, then when it gets rescheduled, it's going to get rescheduled with new values. So something, maybe the next step to think about if you're become more comfortable with the VPA. And the final way is the fully automated, which is not even fully recommended on the documentation. It's still which is basically the completely automated. So the VPA is going to force the rescheduling of your pod with new values if those mismatch a lot. Cool, let's see a demo of that. So the first thing that we've done here is to deploy the VPA controller. So the vertical pod autoscaler is not a component that comes by default in many Kubernetes distributions. So you have to deploy it on top. Here we've only deployed the recommender because we are only going to be using it on the recommended mode. And we have here our front-end deployment. And we have requested 100 millicore and 100 millibytes for it. So to know whether it's going to be enough or we need to change something, we create a VPA object. So once we have that controller deployed, we can create this type of object, which basically tells the VPA, watch the front-end deployment and give me a recommendation. That's why update policy is off. So we've already been running this for a while because we needed to gather that data. So VPA, the object is there. And if you describe that object, then you're going to get values for a lower bound, an upper bound, and a target. And we can see that CPU, we got it more or less right, but memory, we were way off. We need a lot more memory. So something that probably we need to think about and change. And you would need to do this for every object that you want to watch, and you have to describe the pod and do all those things are a little bit tricky. So the people at Fairwinds has this fantastic tool called Goldilocks, and maybe Kendall, you want to?
Yeah, I mean, at a high level, our experience at Fairwinds is that most people don't use the vertical pod autoscaler. They're intimidated by it. They're afraid to trust its recommendations, whatever. I mean, a lot of the things that Ara just covered. And Goldilocks is called that because it's a way to get your resource requests just right. And that's what it's shooting for. So this is a tool. It's completely open source that just makes it easier to get all of your instance sizing or resource request sizing right. And thanks for the plug, Ara. Turn it back over to you.
Cool. So let's move to talk about horizontal scaling that has a lot more involved. So what is horizontal scaling in Kubernetes? So horizontal scaling talks about the number of replicas for a pod. So let's imagine that we have this pod, we have 2 replicas of this pod already running, and we want a third one. So how do we do that in Kubernetes? So there is 2 ways to do that. The imperative way, in which we tell the API server, please give me 1 more replica, or the recommended way to work in Kubernetes, which is the declarative API, in which you tell the API server the result that you want to see in your cluster. So in our case, the result that we want to see is that we want in the end 3 replicas. So we can do that. We can tell the API server, I want 3 replicas. And what it's called the reconciliation loop, what it's going to do is that a component called the replica set controller is going to check how many replicas do already have running. It's going to see that there are 2 replicas, and it's going to tell the scheduler to add a new one. And that's basically horizontal scaling. You can do it manually if you want, using changing your pod configuration, your deployment configuration, sorry, or using kubectl scale. But ideally, you would like to do this again automatically based on some data. And that's exactly what this other component in Kubernetes tries to solve. So how many replicas of a pod do I need based on data? And the easiest way in which it works is using resource usage. So object data, basically. And let's imagine that we have this pod definition that you have 100 millicore and 500 millibytes. That's what you're requesting. But you want to keep that fairly, you don't want that to peak a lot. So you can create an HPA object that says, okay, for the resource CPU, keep the average utilization to 50%. And one of the reasons why you wanted to do that, you would like to do that is, for example, if you have a workloads that have spikes in CPU very often, and you don't want the scheduler to think that you're over utilizing your resources, there is a way to keep it a little bit average. And the HPA, what it's going to do is that as soon as it goes above that target, it's going to start creating new replicas. So let's see that on the demo. So using the same thing, so we are using the same deployment, and we are going to create this HPA object in which we are going to tell the HPA, okay, I want a minimum of 1 replica, maximum of 3 replicas. So you can decide how many replicas you want maximum for my deployment front end. And I put very low, 20% of CPU average, which is probably going to be above that, just creating the HPA. So you apply that object, and after a while, you can see that the target is already above that one. So the HPA, as soon as it sees that it's using more CPU than what it wanted to use, is going to start creating replicas. So you can see here that we had just 1 replica before, and now we have 3, which was the maximum. And this is more or less how you would see that, for example, in Datadog. So you can see the CPU going up and the number of replicas going up. And when CPU goes down, then the number of replicas goes down as well. So this is very useful to, again, to basically do those scaling events without having to think about them, or even doing overnight when your team is sleeping. Good, so it's a good start. I mean, now we can use object data like resource information to drive those scaling events. But usually when CPU and memory is not something our users care about. Like usually when you start gathering metrics about a particular application or service, you use a framework like the four-component signals, for example, which are latency, or the amount of time that your service does some work, errors, the number of errors, traffic, or the amount of work that your service is doing, like requests per second, and saturation, or the amount of work that your system cannot do. For example, if you have all the pool filled. So good thing is that there is a specification called External Metric Server in the HPA implementation that tries to solve that. Like, how many replicas of a pod do I need based on any metric data? And the External Metric Server is a spec that any metric provider can implement. So it's basically a spec that, again, any provider can provide, so they can publish their metric values based on something that the HPA is going to understand. Datadog implements this through the cluster agent. So I was saying that it's not only used to gather information about the API server, but it also had some other features on top. This is one of them. So it implements this specification. So basically what it's going to do is it's going to gather the metric that we need for a specific HPA object, and it's going to expose that metric on the external metric server. So the HPA controller is going to be able to gather that information from them. So thanks to that, we can create HPA object. The same HPA object is not a specific new object or anything, with something a lot more interesting, like using a metric name, in this case, like latency, match some labels, which in our case in Datadog, we match to particular tags. In this case, we want to select the store from 10 and put a target to that metric value. So let's see that in the demo. So we have here the front end, which is getting a latency of 5.6 seconds, and we don't want to grow a lot. So we are going to create this object, put a minimum and maximum of replicas, but using an external metric, which is basically the P99 latency. And we want to make sure that the P99 latency doesn't go above 6 seconds. So again, same thing. We need to create the HPA object by applying that definition. And we are going to start gathering that metric from Datadog. So at that point, the cluster agent is going to gather that information from Datadog and expose it as the external metric server. We can see that it's 5.3 seconds more or less. So we are going to apply a lot of fake traffic. Let's mimic that it's the first day of sales, and suddenly we have our website, our e-commerce application with a lot of more traffic. And this is going to happen after some seconds, some minutes. You can see the latency going up a lot and the HPA creating those replicas automatically. And as soon as the first day of sales ends and there is no one on our e-commerce app again as usual, then it goes down. And again, the HPA is going to do the same and it's going to scale down your deployment. So again, very, very useful to have these features on in order to make those decisions automatically. Cool. So there is one thing that is fairly new. So if you're running Datadog, if you're using Datadog, and you're already using the cluster agent, if you're running the cluster agent 1.7 onwards, you have this new feature called DatadogMetric, and I'm going to explain why this one is interesting. So the HPA object is a little bit strict on what you can do with it for now. So you can select a metric, a selector for that, for the different services, and a target value. But usually when you want to know something about your application, you end up sometimes with complex queries like, okay, give me all the requests that happen every 10 seconds and then roll them up in 60 seconds buckets and give me the average, or something that is important for your business. We couldn't do that with the HPA object. So Datadog has created a CRD. A CRD is an extension of the Kubernetes API server. So it's a very easy way to create new objects on the API, Kubernetes API. And this is basically a way to tell the cluster agent that you don't want just a metric, you want a full query. And it's interesting because in this way you can create the query that you want with any features that you want. And for example, here you already have the selector. You don't need the selector anymore because it's now part of the query. So how we make that that the HPA can understand? So the HPA again is fairly strict. That's the only thing that it's going to allow for you. So we create this fake metric name called DatadogMetric, then the namespace of the object, and the name of the Datadog metric, and also, of course, a target value. So for this one, for example, we have Datadog metric is called frontend hits, and it doesn't say what namespace, so it's the default namespace. So basically, we create the HPA object, specifying the default namespace and the name of the Datadog metric. And the cluster agent is going to do the magic for you. So let's see the demo for this. So here we have a Datadog metric object with our long query that we want to, that we care about for our business, basically. Like any object, even if it's an extension, you create it the same way, and now you have it here. Right now it's not active because there is no HPA object that is using it. So we are going to create the HPA object, and we are going to tell it the metric name with this trick that we have that the cluster engine understand, and we are going to apply that. And at that point, basically we have an HPA object, just normal one, and we can see that the cluster agent is going to start gathering, hold on, this went too quickly. So it's going to start gathering values. So right now we have 5 requests per second on average in a minute. So let's create that fake traffic to force this to be scaled. So when we start watching the HPA object, we can see that the average number of requests went up to 42, which is way above average, above the target. So it started creating that number of replicas. It's still above the target after that, but because we set that maximum, it's going to leave it there. So something also that you need to take into account, that how many replicas at the maximum do you want to have. So we can see it here that the number of requests went up, and the deployment, the number of replicas went also up. And same thing, as soon as our sales day finishes, the number of requests go down and our number of replicas go down as well. Cool. The final thing that I want to talk about is something that we call in Datadog Watermark Pod Scaling. So we've seen that with the HPA, it doesn't matter if you use DatadogMetric or not. With the HPA, you basically selected one query or one metric and a value. But it feels like obviously it can be fine-tuned, the HPA can be fine-tuned, but it only has a value. So as soon as it goes below that value, depending on that definition, it's going to go down at some point. So having just one value seems to be a little bit too inflexible. So for that, we have created something called the WPA, or Watermark Pod Autoscaler. It's an open source project from Datadog, so you're free to use that whether you use Datadog or not. And basically what it's going to do is going to have 2 values for the metric, so a high and a low watermark. And in between those 2 values, there is no going to be any scaling events. So if you have a metric that changes a lot, you can make sure that in that band, you're not going to have any scaling events. Because scaling events are not free, in the sense that you require some CPU to start that pod, to remove that pod, etc., etc. So you cannot be having scaling events all the time. It has also some other features, like you can specify the scaling velocity for each of those WPA objects. Basically, the number of scaling velocity is the number of replicas that you want to be increasing or decreasing in a chunk. And also cooldown periods, like waiting some seconds between any scaling events. These two features, by the way, scaling velocity and cooldown periods per object, is something that it's now also on HPA, on the actual Kubernetes HPA, starting on the 1.18 release. So if you're running 1.18 release, you can also specify for the HPA scaling velocity and cooldown periods per object. You could do that before on HPA, but it was for every object and not per object. Cool, so let's see the final demo. So again, this is a component that is not by default in any Kubernetes. So you have to deploy it. So we have deployed here the controller. And once we have the controller, we can have a new type of object called the Watermark Pod Autoscaler. Again, similar to DatadogMetric, there is this concept of CRDs in Kubernetes that allows you to create new objects to extend that API. So we have created that object. We say minimum 1 replica, maximum 9 replicas. For the P99 latency again, we could have used as well a DatadogMetric as well, but in this case, we only used just a metric name. And we put 7 seconds, maximum 4 seconds, low watermark, and same thing. As any object, we need to first apply the object. And once we have applied that object, we can see that we have that front-end WPA object. So again, this type of if you're using an external metric server like Datadog, in this case, Datadog is going to gather that metric from Datadog itself through the cluster agent. This is the same for HPA with external metric server. So just so you see it once, you can see that the cluster agent is gathering that metric back from Datadog. So we have that value, and again, we mark 7 seconds and 4 seconds, so we are going to put that traffic up. And this is what happens after a while. So you can see that the latency goes up as soon as we create that fake traffic. And these are the number of replicas. And some interesting things that happens here is that it goes a little bit step by step because we added that scaling velocity. And the interesting bit is that it just stayed at 6 seconds. So at 6 seconds, everything went well. And we decided to remove that fake traffic. And the latency goes back to 5 point something. But the number of replicas doesn't go down. And that's because we just, for the sake of the demo, we really selected a very low watermark. The low watermark was 4 seconds. And because that latency never goes below that number, the number of replicas stay at 6. So again, something to tune for your particular service as you need. And that's what I had for today. Some takeaways. The VPA can help you maximize your host utilization without getting a lot of rescheduled pods. So very useful to, at least on recommended mode, to get those numbers right. And the second is that HPA can automatically horizontally scale your pods based on resource or object data, which is a great start. But it's also a lot better if you use it with an external metric server. It can be Datadog, any other implementations of the external metric server, to basically do the same thing based on the data that our users care about, like latency, etc. And finally, the WPA, Watermark Pod Autoscaler, basically what it does is it extends the HPA to allow for more fine-tuning of those scaling events, to avoid having just going down if you don't want to. And that's it. Thank you very much. One thing I wanted to mention is that, I don't know if you know Katacoda. Katacoda is an environment where you can learn things about computers, DevOps stuff. It gives you a full-fledged environment for you to play with. for free, so it's free. If you go to that URL, if you're interested in trying this out for yourself without having to create a cluster, there is a category scenario here that basically allows you to go, explains all the same stuff that I explained today, but in a more hands-on way. So you can go and try the VPA, try the HPA, et cetera, step by step, and using a full running environment. So thanks.
Is that a course taught by you, Ara, on Katacoda, or is it?
Yes, it was created by me, yeah.
Even better, cool. Okay, well, we've got a few remaining things and then we'll wrap up. Ara, can you give me back screen sharing and I'll put up the So first of all, I mean, first of all, let's jump back into this, Dave, if you want to pull up the last poll. This is mostly for our internal understanding of just where folks get caught up. So we'd love to hear your answers on this. But I do want to say, Fairwinds has been a long time Datadog partner. We've 5 years ago made a decision that we were going to point every single one of our customers to Datadog. We've been doing Kubernetes a long time. Building, maintaining, and running Kubernetes is hard at scale, and we have a whole bunch of work done around it, but we made a decision early on that we didn't want to also have to build, maintain, and run something like Prometheus that was self-hosted. And there's just a lot of things that Data does really, really unusually well and makes it easy. And we highly suggest it as a default go-to option. Yes, you pay for it. Yes, it's worth the paying for it, unless you're just at such outrageous scale that you can't afford the bills. But usually if you're at that outrageous scale, you can afford the bills. So take a look at that. We do, one of our open source projects is called Astro and is specifically about integrating with Datadog. So it modifies your Datadog monitors based on the state of the Kubernetes cluster at the time. So that's something we found very useful. We've applied across all of our clients. So if that's something that's interesting to you, Fairwinds Astro. And thanks, Ara, for talking about this Watermark project. That's super interesting, and I've gone back and shared it with some of our folks. So upcoming Kubernetes clinics on October 29th, we have one coming up on Kubernetes cost considerations with Cloud Zero. And then we have one with Ambassador Labs, November 10th, and an open source one, November 12th. So if you're interested in more of these, we're going to keep doing them. And finally, as a last takeaway, if you're interested, Fairwinds has a free Kubernetes assessment. You can go to our website and download that. It's fairwinds.com/Kubernetes-assessment. It's a good place to go get started. It's going to give you some hard feedback on where to go, what to do next. And that's a good place to go dig in. So thank you very much, Ara, for speaking. We really appreciate Datadog attending and you representing.
Thanks to you for inviting me.
Especially as we can tell the sun's going down in Spain. So really appreciate it. Thank you to everyone for attending. We do have a few minutes left for questions, and we've had a few questions come in. Let me see, just a second, let me pull those up. First question, Ara, do I need a Datadog account to use its external metrics server provider?
Yes, you do. Basically what it does is the cluster agent will pick the specific metrics from Datadog. So first you have to have the data in Datadog, then you can use that external metrics server. You can go to datadoghq.com for a trial account if you want to give it a try. Okay, and somebody did type in a question here that it looks like Dave answered, but just to share with everyone, this is being recorded. The demo was recorded as well. It says the demo was awesome, Ara. I need to show this to my boss. So yes, it will be recorded and it is going to be published to YouTube probably by the end of the day tomorrow. It looks like Dave answered that in there, but just for everyone's sake. Also, another question in here. We've seen that for the vertical pod autoscaler, we had to deploy a controller. Do we need to do the same thing for the HPA? Or does HPA come built in? So the yes and no. So there is also a controller for the HPA, but it comes by default in most Kubernetes distributions. Maybe Kendall, you know more. Is there any Kubernetes distribution that doesn't come with the HPA controller?
If there is, I don't know about it. And like I said, I mean, this is some of the fundamental beauty of Kubernetes is at least horizontally scaling. Even if you never vertically scale, at least horizontally scale. And so, yeah, I think it wouldn't make sense to me to have a Kubernetes distribution that doesn't have it by default. But yeah. Okay. And I'm curious, Ara, are there any other open source projects that come off the top of your, are top of mind for you that Datadog's doing in the Kubernetes space that are relevant?
So yeah, they're doing something called the extended daemon set, which is basically the daemon set as we know it and love, but with more features, particularly regarding how you roll update that daemon set, et cetera, based also on data. And we did it first to around each. So basically as we deploy a lot of times the node agent, which is a daemon set, we wanted to have more control when we upgraded it in our internal clusters. So we created something called the extended daemon set, which has a little bit more features.
Okay. And I don't see any other questions that folks have sent in, so we'll wrap up. But thanks again, Ara, and thanks everyone for attending. Have a good rest of your day.
Bye. Thank you.